Hi everyone, this is another lesson on physics and on the topic on kinematics. And today I'll be talking about acceleration due to free fall. Okay, and for the pure physics class, there is an extension, and that is where you need to understand what is terminal velocity. So I will just be teaching today about these two concepts, and this will round up chapter 2 on kinematics. Okay, so let's start. Now let's consider an object falling down. So now when I draw a box, it doesn't really mean, or I draw a square, it doesn't really mean a box, it just means an object. Okay. Now in an environment where you drop anything down, we see that the speed or velocity will increase. It will just get faster and faster as it falls down. But understand that when you drop something lighter, it seems that this lighter object is increasing its speed at a lower rate than this larger object. And that's because we have air in our midst. Okay, that's when air is all around. So for a moment, many years ago, and all this while, people always think that the heavier the object, the faster it will fall. Simply because air is working on this. So this is actually wrong, right? And I mentioned in my class that Galileo actually did prove that this is not right. So how do we treat this whole subject matter? I want you now to just consider without air. In a space without air, that means it's a vacuum. So there is no air particles to resist anything that drops down. So it can be a big box, a small box, feather, sphere, whatever mass this object has, they will all fall at a constant rate. Or should I say, fall at an increasing velocity, which means that it's getting faster. And both of them are getting faster at the same rate. That means if there is no air, it takes the same amount of time for these two objects to reach the ground. And I show you through a video where all the air is all taken out in the vacuum chamber, and you see how the bowling ball and the feather fall at the same rate. Okay, so now this object fall at a constant acceleration. This means that the velocity or the speed is increasing at a constant rate. So what is the constant rate? This constant rate is approximately 10 meters per second square, and this is known as the gravitational acceleration. Gravitational acceleration of 10 meters per second square. What do you really understand this? Now, don't memorize just by the fact that it's g equals to 10 meters per second square. Understand this, that for every second, for every 1 second, the velocity increase from 0 to 10 for every 1 second, for 10 to 20, and so on and so forth. So it's getting faster and faster. For every 1 second, it increases by 10 meters per second. That is how you should understand by this acceleration is a constant at 10 meters per second square. Okay, so how does the graph looks like? VT graph. It will start at 0 and the speed will increase at a constant rate. So this is going to be a straight line. Increase at a constant rate. Regardless of the mass, all objects will fall at this constant rate, as you have seen in the video. Okay, so this is actually gravitational acceleration. There are a few names for this. So G can be gravitational acceleration. Gravitational acceleration. Or G is also known as gravitational field strength. Think about this word. It is the strength of the gravitational field, and gravitational field is really a space where gravitational force can be felt. So it's 10 meters per second square, or you can have it as 10 Newton per kg. Now you may not be very familiar with this. This will be covered in chapter 3, okay? All right, chapter 3. Okay, so yep, that's it. This is your gravitational acceleration due to free fall.